For 30 years, one promise defined the performance estate segment. Porsche makes it, everyone else copies it. That promise died quietly, not on a racetrack, not at a motor show, on an assembly line in China, where engineers looked at everything Stuttgart had built, studied every limitation, every physics compromise, every pricing decision, and then systematically dismantled all of it. The Zeekr 7 GT is not a challenger. It is a verdict. 900 volts, 784 horsepower, a chassis governed by artificial intelligence that physically reacts to danger before your brain registers it, and a full charge recovered in the time it takes to finish a coffee. Today we are going to go deep into the blueprint, and by the end of this video, you will understand exactly why the engineers in Stuttgart are no longer ignoring this car. They are studying it. To understand why this machine represents a genuine structural threat to the established order, you need to understand the geography it was designed to conquer. The British B-Road. Narrow, unpredictable, with sudden cambers and blind crests that punish poor chassis tuning without mercy. The German Autobahn, where sustained high-speed stability separates serious engineering from marketing literature. The canyon roads of California, technical and demanding, where a car's suspension geometry is exposed in real time. And the vast thermal highways of the Australian outback, where range management and heat endurance decide whether a vehicle is genuinely capable or just impressive on paper. For decades, these environments belonged to a very specific category of car, the high-performance estate, the shooting brake, vehicles built in Stuttgart, Munich, and Ingolstadt that combined practical cargo space with the kind of chassis dynamics that made drivers feel genuinely connected to the road. But here is the problem. Legacy architecture has been quietly running into its own walls. The 800-volt electrical platform, for years marketed as the premium benchmark for electric vehicle charging speed and power delivery, is no longer the ceiling. It has become the floor, and many traditional manufacturers are still struggling to properly integrate even that. Heavy, poorly packaged battery modules compromise center of gravity placement. Software architectures built on legacy automotive operating systems slow down the kind of real-time chassis computation that modern driving demands. And the fundamental physics of high-performance estate dynamics, specifically the pendulum effect created by rear mass concentration, has never been properly solved. It has only ever been managed. The Zeekr 7 GT does not manage these problems. It engineers them out of existence. Let's start where most people start when evaluating an electric vehicle. Range anxiety. Because no matter how impressive a car's chassis dynamics are, none of it matters if the driver is psychologically trapped by battery percentage numbers. The electric vehicle industry spent 5 years positioning 800-volt architecture as the definitive solution to slow charging. The Zeekr 7 GT bypasses this benchmark entirely and implements a fully integrated 900-volt high-voltage platform. To understand why that matters, you need to go back to basic electrical physics. Power equals voltage multiplied by current. To deliver high power, whether for performance or for rapid charging, you must increase one of these two variables. Increasing current is the expensive, heavy, thermally dangerous option. High current demands thick copper wiring, oversized cooling circuits, and thermal management systems that add weight and complexity. The alternative is to push voltage higher, which allows you to deliver the same or greater power at significantly lower current levels. Lower current means less heat generation, lighter wiring architecture, and a system that does not need to throttle itself to prevent thermal damage under hard driving conditions. At 900 volts, the Zeekr 7 GT operates in a different thermal regime to its competitors. This directly enables the Golden Brick battery technology's 6C charging rate, a figure that describes how rapidly the battery can absorb energy relative to its total capacity. What does that translate to in human terms? 10.5 minutes from 10% to 80% state of charge. In the time it takes to walk into a service station, use the restroom, and return to your vehicle with a coffee, the car has recovered over 300 miles of real-world driving range. This is not a controlled laboratory figure. This is the result of 900-volt architecture working in combination with a heat pump system that preconditions the battery cells before you even reach the charger, ensuring the chemistry is operating in its optimal temperature window, whether you are arriving in sub-zero Scottish conditions or the dry heat of the American Southwest. Range anxiety is not just a technical problem, it is a psychological one, and the 900-volt platform resolves it at both levels simultaneously. Fast charging means nothing if the car cannot be trusted dynamically. And this is where the Zeekr 7 GT's engineering becomes genuinely remarkable. The fundamental challenge of a shooting brake or performance estate is mass distribution. Extending the roofline backwards to create cargo space concentrates weight over the rear axle. In a corner, particularly at speed, this creates what chassis engineers refer to as the pendulum effect. The rear of the vehicle wants to rotate outward under lateral load, generating snap oversteer. It is not just an inconvenience. In a family vehicle at highway speeds, it is genuinely dangerous. Traditional solutions involve tuning the suspension to resist this rotation through increased rear roll stiffness or adaptive dampers that try to compensate reactively. But reactive is the key word. You are still fighting the underlying physics rather than changing them. The Zeekr 7 GT addresses this through the PMA 2 Plus platform and a cell-to-body integration philosophy. Rather than constructing a separate battery housing and mounting it beneath an existing chassis structure, the battery enclosure itself is designed as a primary load-bearing structural component. The top surface of the battery pack functions as the cabin floor pan directly. This creates a single, unified structural unit with a torsional rigidity figure that surpasses many carbon tub supercars built specifically for track use. The consequences of this decision are felt the moment you enter a corner. There is no chassis flex transmitting through the steering column. There is no delayed, filtered sensation of the rear end loading up. The connection between driver inputs and vehicle response is immediate and direct, and because the 900-volt battery architecture allows for a physically thinner pack, the center of gravity drops to hip height, approximately the same position you would find in a purpose-built mid-engine sports car. The mass that would normally create pendulum behavior is instead distributed low and centrally, transforming the car's dynamic character entirely. The pendulum effect is not managed, it is structurally eliminated. A structurally rigid platform is the foundation. What operates on top of it determines whether the car is truly exceptional. The Zeekr 7 GT does not use passive dampers that react to road inputs after the fact. It runs a predictive digital chassis system built around a LiDAR array integrated into the upper windscreen area. This sensor suite continuously reads the road surface ahead in real time, feeding data into dual NVIDIA Drive Thor processors capable of handling trillions of operations per second. At 80 miles per hour on a poorly lit highway, a driver's reaction time is measured in hundreds of milliseconds. The car's microprocessors operate in fractions of that window. When the sensors detect a surface change, or when steering angle and lateral g-force data indicate an emergency avoidance maneuver is beginning, the continuous damping control system responds before the driver's conscious mind has registered what is happening. Outer dampers stiffen instantly to prevent body roll. Inner dampers simultaneously soften to maintain tire contact patch on the road surface. The car stabilizes itself in the gap between human perception and human reaction. The double wishbone front geometry and multi-link rear setup provide the kinematic foundation for this system to work properly. The same geometric principles found in dedicated track-focused machinery, now governed by algorithms rather than purely by mechanical tuning. Driving the powertrain through all of this is a combined output of approximately 585 kilowatts, 784 brake horsepower, delivered through a silicon carbide inverter in the rear motor. Silicon carbide semiconductor technology allows electrical switching at higher frequencies and with lower thermal resistance than conventional silicon components. The practical effect is zero latency torque delivery. There is no engine note, no gear selection, no rev buildup. Throttle input produces immediate linear force. On corner exit, the all-wheel drive system functions as a torque vectoring unit, redirecting power away from the inside wheel that is losing grip and pushing it to the outside wheel where mechanical traction exists. The car pulls itself through corners with the aggression of a rally car and the interior silence of a business-class cabin. The aerodynamic package reinforces this at speed. The shooting brake silhouette presents natural drag challenges at the rear. Zeekr's response includes a completely flat battery floor, hidden door handles, active front grille management, and a carefully sculpted body that achieves a drag coefficient low enough that at motorway speeds, conversation in the rear seats requires no raised voices whatsoever. When deceleration is required, regenerative braking engages the motors as generators first, recovering kinetic energy back into the 900-volt battery before the physical pads are ever required to work. On a demanding mountain descent, the Rockies, the Scottish Highlands. Brake fade becomes a non-issue because the mechanical system is being preserved throughout the descent. The brake-by-wire system ensures pedal feel remains consistent and confidence-inspiring, regardless of conditions or repetitive use. The Zeekr 7GT was not designed for the Chinese domestic market. The suspension tuning, the shooting brake silhouette, the charging infrastructure targeting, the aerodynamic calibration, all of it was engineered with British roads, European motorways, American highways, and Australian distances explicitly in mind. What this vehicle represents is not incremental progress. It is a structural argument that the assumptions underlying a century of European automotive premium positioning, that heritage, racing history, and badge prestige justify significant price premiums over objectively superior engineering, are no longer defensible. The 900-volt platform is production-ready. The AI suspension system is not a motor show concept. The 10-minute charging window is not a controlled test result. These are systems available now in a vehicle heading to international markets. When engineering this comprehensive arrives at this price point, heritage stops being a differentiator. It becomes, as the spec sheet makes clear, something closer to a liability. The map of automotive dominance is not shifting gradually. It is being redrawn at speed.